Ever wondered what happens when your internet suddenly slows down or drops out? Meet the unsung heroes, fiber optic technicians. Out on city streets or rural back roads, they're the ones making sure your connection stays lightning fast. Picture this, a technician, helmet strapped on, climbing a utility pole with a specialized tool belt. Up close, you see diagnostic equipment like an optical time domain reflectometer plugged into the cable, sending pulses of light to pinpoint the exact location of a fault. Once they spot the issue, maybe a kink or a damaged section, it's time for hands-on repair. Carefully, they strip back the protective layers, revealing the delicate glass fibers inside. With steady hands, they splice in a new fiber segment, using a fusion splicer that welds the glass together so perfectly the light passes through as if nothing ever happened. After a few final checks, the technician descends, job done, your connection is back online, good as new. Without these routine checks and expert repairs, even the most advanced fiber optic network would grind to a halt. It's all part of what keeps our world instantly connected. Ever wondered how you're able to stream movies, make video calls, or send memes across the globe in seconds? The answer? Fiber optic cables. These thin strands of glass literally changed how the world connects. So let's wind the clock back. Before fiber optics, information traveled through copper wires, slow, bulky, and prone to interference. Then, in the 1970s, scientists figured out how to send light, actual light, down tiny glass fibers. Light can carry way more data, way faster, and over much longer distances without losing strength. Imagine sending thousands of phone calls or HD videos all at once, no problem for fiber optics. What makes them so cool? Well, they're insanely thin, about the width of a human hair. But they can transfer terabytes of data per second. That's like downloading a whole movie in a blink. They're also immune to electrical noise, meaning less lag and way fewer dropped calls. Today, fiber optics are the backbone of the internet. Every email you send, every video you binge, every selfie you post, most of it travels through these invisible highways of light under our streets and oceans. Without fiber optics, the world as we know it, streaming, cloud computing, even remote work, just wouldn't exist. Pretty wild, right? So next time you hit send or press play, just remember it's all thanks to a beam of light speeding through a strand of glass. Now that's some next level magic. Let's take a closer look at how fiber optic cables are joined together. First, the fiber is carefully prepared and stripped of its protective coating. Next, it's cleaned to remove any dust or debris. Then, the fiber is precisely cleaved to create a smooth, flat end. Finally, both ends are placed into a fusion splicer, which uses an electric arc to fuse them together, creating a seamless connection for light to travel through. This meticulous process ensures high-speed, reliable data transmission across the globe.